Hello everyone, my name is Manoj Sidhu and today we are going to talk about Anaconda software along with Spyder IDE. A little disclaimer before I start the video is that since this is the first time I'm making a video, I may appear nervous and I may stutter along somewhere. So please bear with me and any feedback is appreciated. Thank you. So let's get on over to the agenda of what we are going to talk about today. So I'll give a brief introduction about the Anaconda IDE along with Anaconda software along with Spyder IDE, and I'll tell you how to install it and a brief explanation about the various features of the Spyder IDE. A quick overview on some of the pre-installed packages and summary at the end of the video and some conclusion. So let's get on with the introduction of the Anaconda software. So Anaconda software, it was developed by Continuum Analytics Company. The CEO of Continuum Analytics Company is Scott Collison. It is a distribution of Python and R programming languages for large-scale data processing, predictive analysis, and scientific computing. So mainly, this software is mainly used by the people who are enthusiastic in data sciences, machine learning, artificial intelligence, and all other cool stuff. It brings various technologies like Hadoop and distributed processing. This is very much important and very helpful in doing big data analytics because, as we know, we have to handle very big amounts of data and it should be as efficient as possible. And it helps in connecting various data scientists since it is an open source tool. This is also another important part of Anaconda. Since it is an open source tool, whatever we can contribute to the community so that our packages can be utilized by other scientists or other enthusiasts. Such as if our package, if whatever the package that we design is more efficient, then it may help others improving it. Thus, collaborating with others, making a joint effort is always a good idea in developing any program. That's my preference, that's my idea. So it provides 720 plus data science packages for tasks like machine learning and deep learning. So since the packages come pre-installed, there is no need or the hassle to install it again and all the other stuff, so hence it makes our life even more easier. It provides native access to data in HDFS and Amazon S3. It provides distributed computing for data science workloads with in-memory persistence and caching. Provides easy access to deep learning packages such as Theano, TensorFlow, Neon, H2O, and many more. These are the packages that that are utilized in machine learning. It also provides packages which make use of GPU for faster computation. As we know, we have to handle very big data or very large amounts of data in big data analytics or machine learning. GPU will be very much helpful in computing this rather than depending on the CPU, since the CPU architecture is not designed for handling large amounts of data at a time. Manage and control versions of data science assets. This is also a very another important feature of the software. Since we will be developing many versions of a certain package, since we'll be developing many versions of a certain package, we will have to keep track of it so that if any bug or any problem appears in further packages, we can always roll back and go back to the previous old working packages. It helps in exploring and interacting with data through powerful, easy to understand visualizations using Microsoft Excel. So visualization is always an important tool in understanding anything, and Anaconda provides bridge an excellent bridge in connecting visualization of data and thus helping the data scientists to understand their analytics even more. So that's the introduction to Anaconda. So let's jump straight to Spyder IDE, which we are going to discuss today. So Spyder IDE, it is an open source cross-platform integrated development environment for scientific programming using Python. So it's mainly an IDE developed for Python, more like data statistics. It is more like for statistical computation, data sciences, and machine learning. It is very helpful. It integrates many important and well-known packages such as NumPy, SciPy, Matplotlib, and other open source packages. So if anyone has worked on data sciences, they will know that NumPy and Matplotlib are very important in there. analytics and in their implemented in their analytic algorithm. So it is released under the MIT license. It embeds it embeds Python specific code quality assurance in introspection instruments such as Pylint. So what this Pylint does is it tries to assure quality by checking for inconsistencies and the normal syntax of the program. We will show the demo in a later bit. So it is available cross-platform through Anaconda on Windows with WinPython and Python XY, on Mac OS through Mac ports, and on major Linux distributions such as Arch Linux, Debian, Fedora, Gentoo Linux, OpenUSCE, and Ubuntu. So these are the various platforms where the Spider is available. And as a mention is that, and another mention is that the Spider comes pre-installed with Anaconda, so you don't have to worry about other installing other softwares to make Spider work. So if you install Anaconda, Spider will work automatically. So the features of Spider is that it is an editor with syntax highlighting and introspection for code completion. It helps in code completion, and it also suggests if you type a half word, if you want some inbuilt function, and if you type half of it and you don't know the other half of it, it tries to complete it for you, and which is very helpful. Support for multiple Python consoles. It supports multiple Python consoles, including interactive Python. The ability to explore and edit variables from a GUI. It offers a graphic user interface to explore and edit variables. Plugins that come pre-installed are static code analysis with Pylint, as I had explained earlier, code profiling, and Conda package manager with Conda. So what this package manager it does is that it helps in installing packages in an efficient and a clean way, rather than a messy way. So it is very helpful in installing packages. So let's the next topic which I'm going to talk about is the installation of these softwares. So when you open your browser and go to Google, you have to type Anaconda Python, Anaconda Python, and click on the first link. You will get a page like this. When you get a page like this, so select whatever the uh, OS you have. For example, if you have Windows, click on Windows, or Mac OS, or download for Linux. Since I'm on Windows, I'll be clicking on this. So basically, if you have and it also depends on the architecture of your system, if it's a 32-bit installer, or a 32-bit system, or a 64-bit system. Since mine's a 64-bit system, I'll choose this option, and it depends upon the Python version which you are well versed with. Since I am well versed with Python 2.7, I'll be downloading this file. Okay, so after clicking on that link and downloading the required file, it'll it'll appear in your downloads folder under the name of Anaconda. Just a second, I'll show it to you. Yeah, here, as we can see it. So this is the main file, and you need to install only this, because Anaconda installer installs both Python and all the other packages, so you need not install Python separately and Anaconda separately. So when you double click on this setup file, it'll open a security warning, so click on run, and it's verifying, and keep clicking on next. I agree. I'm just installing it for me, so next and next. So since I have already installed the software, it will not allow me to install unless I uninstall the previous software. So you just the viewers can keep clicking next, and I agree, and it will install on its own. I'll be exiting the setup since I've already installed the software. So after installing, the Spider will not be visible on the desktop version. So what you have to do is go to your Windows menu and search for Spider. Type spy, and you will get the Spider. You can pin this to your taskbar. Since I have already pinned it, so it's asking for me to unpin from taskbar. Here, this is the Spider icon that I have pinned to the taskbar. So that is about the installation process. So now some quick overview about the features that Spyder offers to the users. I have already opened the Spyder IDE. So this is what Spyder IDE looks like. These are all test files which I'll be showing in the demonstration later. So this is the code. This part is where you write the code that you want to run. This part is where you can inspect objects, variable explorer, file explorer to run through all the other files wherever you have them saved, and static code analysis. So this is the IPython console region. With this, it is almost like a native Python console, but it is interactive since it allows for code completion within the console itself. This feature is not provided in the traditional Python console. So let's get on with the features of the tool. So file, let's start with the file. So new file helps in as you all know, it helps in creating a new blank file. New project is used to create a project is basically where you want to create many files which are interlinked together. So if you want to create an application which runs on many files, so the project creating a project is useful. Open to open the files, open recent, or it will show you whatever the recent files you have opened. Save all saves all the files, and save as saves as whatever the file name. Since it gives us untitled 4, you can save it to whatever the name you want. So I'll show you where the files are actually stored. Go to this PC, Windows C, users, mine's Manoj Sidhu, so I'll go here. It'll be under .spider2, and you can see all your saved files are here. These are the files which I'll be showing in the demonstration today. So as you can see, they're all saved here. Okay, so next is reverts any action whatever you have done before. Print a preview, so it helps in printing if you want to print your files or the images, whichever whenever you write the program. Close the current file, closes all the files, and load session if you some session which you couldn't complete at certain point of time, you can save the session and quit, then load the session. Quit is to exit the IDE altogether itself. Next we'll move on to the edit section. Edit section basically represents whatever the changes you make to the IDE whenever you write the code. So undo rerolls the rerolls the action whatever you did before clicking this option. Redo reverses back the undo. Cuts the, as we all know, it cuts the text, and copies the text. Pastes the text, and delete means deleting the text. Selects all the text. Comment or uncomment. This is very helpful in writing programs, since we all know comments make the program very much eligible and readable also, to thus helping other users slash programmers to understand whatever you have written. Add block comment. If you want to add a comment block or comments with multiple lines, you can use this option. I'll show you like here. It commented multiple lines, it commented everything. So undo option, if you press Ctrl Z, it will get undo. It reverted back my action. Remove comment block to remove any comment blocks. Indent and unindent. So as we all know, Python programming mainly depends upon the indentation of whatever you have written. It does not use parentheses like C, C++ or Java. So indentation like giving 2 spaces or giving 4 spaces is very much important, and this indent I will help in indenting your text according to the Python standards, and unindent will help in unindenting the text. Search. So find text. So if you have written a very big program and you want to search for something, I can type like find next and type hey. It highlights hey. So it's very helpful. So find next means it will try to find the next word which has hey substring in it. Find previous means it will try to find the hey substring in any word before the searched word. Replace text, so it will replace the text with any text. So I'll show you the demo. Replace hey with hello. So it replaced hey with hello. And go to line, so if you want to go to any line, so say suppose I want to go to the third line, it will put the cursor there. And it is very helpful if you have written a very big program. So find in files, so if just as I said, if you have a project where you want multiple files co-working together, which are co-dependent on each other, and you want to debug the files due to some variable error or some mismatch of variables, you can click this option and type for the word whatever you want here, find in files. This option you will get, and you can find whatever the word that is giving the error and find it and debug it. Okay, so next is source. So okay, convert end of line characters. So this is very important in going to the next line, since the next line will be very much different in Windows, Unix and Mac. So you have to select this based on what is your OS. Show blank spaces, this is also very much important. Suppose I write some function. Okay, I'll show the first without the blank spaces. Okay. So if I run this function now, it will print hello world. Suppose in the next line you forgot that you have put 4 space and go with the convention of putting 2 spaces. It will show you an error. It does not match any outer indentation level. Since you have given here 4 space and you have given here 2 space, the Python is telling that this is not matching with any other outer indentation level. So you either have to make this as 4 space or make this as 2 space. So to help make to know how much space you have given easier, you can show it as show blank spaces. Here you can see you have given 4 spaces, 1 2 3 4 4 spaces. Here you have just 2, so 4 spaces. The error is gone, so this function will run now. Removing trailing spaces, so trailing spaces basically means that if you have given many spaces like this, and if you select remove trailing spaces, it basically deletes the extra spaces given after the statement code, a statement or code line of code. Fix indentation, so it basically converts if you have given the 4 spaces and 2 spaces, just as I said in the example, just as I shown in the example before. If you have given tab instead of 4 individual spaces, it will fix the tab space to match with 4 individual spaces rather than just one tab space. So this is very much helpful in replacing the tab characters with space characters. So run static code analysis, this is very useful. I'll show you with an example. So this is a code which I had already written before. When you run the static code analysis, it will show you the total global evaluation of that particular file. With the help of this, you can see wherever the excuse me wherever the convention, the basic convention, if you're not following, it will show that a refractor and warning. So let's have a look at convention. For example, you don't need the in Python 2.7, you don't need this parenthesis. The but it doesn't mean that it will not work even with parenthesis, but that's not the convention. So hence it is showing unnecessary parenthesis after while keyword. So with help of this, you can get to know the convention of that version of Python, like Python 2.7 or Python 3.6. In Python 3.6, these parentheses are very much necessary for while running the code. Since I'm running Python 2.7, they are not as much as necessary. As we can see, it has given uh, all the warnings which are not of the convention or the standard rule. So the refractor, in the next refractor, it will show you that there are not many arguments or not too many statements. It will show the variables or the arguments that you have entered here. In the warning statement, for example, here I have declared as a name, but I have not assigned it anything, and I have declared it as global. So for one thing we have to understand about the Python is it is an interpreted language, means it will try to compile and run every single statement rather than compiling the program as a whole, like in C, C++ or Java. Hence, when it first finds the global name, it will not find any initialization done to it. Hence, it's showing this warning rather than an error. Because if you are using this name without initializing it properly anywhere, it will have some sort of uninitialized garbage value in it, which may lead to program termination and other problems. Hence, you have to keep track of the initialization and uninitializations. Hence, this static code analysis will be very much helpful in finding out the initializations and uninitializations, as we can see here, using global for name, but no assignment is done. So the next is run. Okay, I'll delete this. Whenever you want to run whenever you want to run a file, you just press this button, or you can go to run and press run. It will print hello world and hello. If you want, okay, so cells are a feature in Spyder. Cells are very much important in running only particular lines of code. I'll show you an example. So the cells, to make a cell, code of cell, the syntax is hashtag percentage and percentage. It will create, as you can see, it will create it will display a line showing that this will be whatever the statement that comes after this will be belong to this cell, code cell. So print. So if you want to, if I just want to run this particular cell rather than running uh, this cell and this cell, so if you want to just run this particular cell, place your cursor near the cell which you want to run and go to run and press run cell. So it just prints hello YouTube. So to make things easier, if you want to run the cell and advance to the next cell, you can click this run cell and advance. As you can see, it prints the hello world and moves the cursor to the next cell. Once again, run cell, and it again prints hello and comes to the next cell. So it becomes easier to run each cell rather than making your cursor, pointing your cursor to that particular cell. It is very much easier to do this. Run cell, and next the thing is run selection or current line. So if you want to run just a particular line of code, you can put you can select this option. So hence it just ran this code rather than running the whole file. Rerun last script, whatever the last script you have run, it will try to rerun it for it will try to rerun it. Next is configure. So if you want to configure, this is the configuration as to where the output of the program will be. So whereas, as we can see in this example, whenever I run the program, it will be output in the IPython console. You can change it here, like executing current Python or IPython console, execute in a new dedicated Python console. You can create new Python consoles in Spyder, execute in an external system terminal. If you have an external system terminal, you can make the output print on that, or get the file to run on that system terminal. If you want to have any sort of command line options, like if you want to run up if you want to run a file in Python 3.6, you have to give the command line as python -3 and python that file name .py. So command line options there will be -3. So those are called as command line options. So working directory, my working, as I showed you before as to where the files are saved, that will be the working directory. You can change it by selecting this and browsing to whatever the folder you want. If you have a dedicated Python console, you can make changes here as and when necessary according to your requirements. So this is the profile. Since I don't have any a project or stuff like that, it will show the profile like 10th March 1644 as to what we are doing at that. It will be helpful for documentation and stuff. So I'll close this. So next is the debugging. So whenever you know you have an error in your code, in your program, or in that whatever the file you are writing the code, excuse me, so you can use the debug option to run. So what it does is, these red dots are called as breakpoints. So what it does, this debug option is, it will try to run the file until it encounters a breakpoint. So let's test this. So when you click on debug, it got exited here. The file stopped running at this point. As we can see, uh, author Manoj Sidhu, triple quotes, and the cell syntax. It did not run this hello world. So it becomes very helpful in finding out if you have any errors in some sort of variables or not. Uh, it got exited here in the first debug. So after exiting, if you have multiple breakpoints, it will try to it will first debug it here. If you want, it will show whatever the variables you have, and or how the things are happening there, and it will try to and it will exit at the next breakpoint. So it will become very helpful in managing your variable values. If you have many variables and you don't know how the variables are changing, these breakpoints are very helpful, and debug feature is a very helpful feature to debug the to debug your program if you have a very big program. I'll exit this. You can exit any current command by pressing this red button, and it will exit out of it. Next is the breakpoint. You can set or clear breakpoint. So for example, I've already set a breakpoint here. So if I want to clear the breakpoint, I can click on this and the breakpoint will be cleared. There is no red dot. So if you want to again create a breakpoint, set a breakpoint, you can edit it here. So the breakpoint has appeared. These are helpful in conditional breakpoints. So if some sort of condition happens, if that condition is satisfied, then a breakpoint will appear at that point. This is very helpful in advanced debugging. If you want your function, your very big program to work in some sort of way, but it is not working like that. So debug control. Basically, it tells is that step when you first encounter the first breakpoint. By pressing this, it will go to the next breakpoint. And stepping into means if there are two breakpoints and then there are statements in middle of those two breakpoints, it will try to go into the statements between those breakpoints. So step return from wherever the breakpoint has appeared, will try to return to the previous statement. Continue debugging and exit debugging. So consoles. So these are basically called as consoles. So IPython, the IPython console, this is IPython console. This is the internal console of the Spider. This is where all the backhand stuff appears or they take place. This is the this is the console, and this is the history log. As you can see, it will show you the history of whatever the code you have written. So the difference between the traditional console and IPython console is that whenever, for example, I'll try to explain this with an whenever you try to write a code, it will give you some sort of suggestions. So for example, I'll create a list and I want to find the sum of it. So uh, as you can see, it appeared as like object. It tries to give you the whatever the argument you have to fill within the parenthesis, the a dot append. So we have to append any other, if you have to append any other, say 4 to the existing list, then it showed that you have to append an object. So that is the advantage of ipython console over the traditional python console. 1 2 3 4. So this is the ipython console. This opens the traditional python console, and if you have an existing kernel, it tries to connect to it. So tools, preferences. So it basically depends on what your preference is, like using a single instance, vertical doc widget title bars, vertical doc widget tabs, or run how you want to run it. So you can change it here, the what according to your preference, like keyboard shortcuts. If you find some your own user keyboard shortcuts more easy than whatever the default has been assigned to it, you can make changes here and make your life more easy. Next is the Python Path Manager. So basically what this does is, so if you have installed since you install Anaconda, Python also will be installed in Python also will be installed. So if you want to work with just Python and not Anaconda, you have to specify, you have to specify the executable file of the Python. I'll show you with an example. This PC Windows C. So I have Python installed here, Python 2.7. So whenever I want to work with Python 2.7, I have to come to this folder and open the command prompt here, or type or work with the traditional Python console. So this is the traditional Python console. So if you want to run a command prompt first, if you have a file say somewhere on the desktop and you want to run the file from the desktop, then you have to specify the path of where the Python executable is. So here Python executable is here, this PC Windows 8 C drive, Python 27. So you have to specify this path if you want to work elsewhere. So you can do this by going to properties, this my computer or this PC properties, advanced system settings, advanced environment variables, and path. As you can see, it has already been since I installed it, it is already here. So if you want any user program, anything other than Python to work outside from its specified directory, then you have to specify the path of the executable file in this region. So that's the use of the Python path manager. Okay, so moving on, current user environment variables. So as I showed before, we can change the environment variables by going to this PC, advanced properties, advanced settings, advanced tab, environment variables. But you have to be very careful as to what you do, because while install the path many there will be many path indicating to the system directory. So you don't want to mess with that. So if you mess with that, the other applications which are dependent on the core important system files, if you delete those, then your computer, there's a possibility that your computer may malfunction, and it will lead to a lot of problems. So that's what it's showing as the warning. Use it and at your own risk. So you have to be very careful while modifying or adding any sort of path to the environment variables. As you can see, path here it is specified as Anaconda, Java Home, temp. Okay, so moving on, update module names list. So it tries to update whatever the modules you have, and it updates the list. Also open command prompt is, so if you have open command, it opens the command prompt of the Windows. If you have Ubuntu, it tries to open the terminal. So since I am in Windows, it tries to open the command prompt of the Windows. So this is the command prompt. view. So this is basically depending on your what you want on your screen. So for example, view panes. So if you want editor console, yeah, if I don't want IPython console to disappear, don't want to appear here, so IPython console is not here. If I want it again, IPython console appeared. So it basically depends on how you want your IDE to look like to make your IDE more beautiful. uh, Toolbars like file toolbar, run toolbar, all this stuff. So attached console window debugging, full screen mode or maximize current pane, close current pane, so if you want to close the current pane, and custom window layout help. So if you are very much new to the Python programming, or if you are very much new to the program, I highly recommend you to first learn Python tutorials. There are very good Python tutorials out there. You just google it as Python tutorial and you'll get lots of very good tutorials on Python, or else you can refer to these documentations and get an idea of the inbuilt functions and about the other features, other awesome and amazing features of Spider here, like Spider documentation. Or if you want to report an issue that you are experiencing with Spider, you can report it to them and about Spider. Okay, so I should have mentioned this earlier, but after installing, you can after installing Python and Anaconda. So if you install Anaconda, it will already Python will already be installed. So if you want to check whether Anaconda and Python are installed or not, just try typing Python. So it will show Python 2. Version Python 2.7 and Anaconda 2.4.0. Hence, Python and Anaconda are installed in my system. So this is the confirmation that you get after installing Anaconda. So to make this command work anywhere, so you have to set the path to the Python executable file that I showed you in the how to set the environment variables. So if you want to know what are the packages installed along with the Anaconda, you have to type in the command pip list. It will show whatever the pre-installed packages that come with Anaconda, like Anaconda client, uh, beautiful soup, feed parser, Jupyter, Matplotlib, NumPy, SciPy, Pandas, and all the other stuff. So these are very much you don't have to install these softwares again. So if you want to install any other packages, you can always give us pip install package name as an example. So when you type this, it will try to fetch the through the internet connection. It will try to fetch the whatever the package that you require from its repositories. So this was a brief work and quick overview about the. Okay, so before I finish the quick overview of the IDE, here are the object inspector. So if you want to inspect any object like print or other inbuilt functions, it will be displayed here. Variable explorer, you can see the various variables that I used in other programs appear here. File explorer, as I said, to see wherever you have other files located, and static code analysis, as I showed, to see the various conventions and the standards used in that programming languages. So okay, that concludes the brief and quick overview of the Spider IDE. So now I want to next I want to discuss about some pre-installed packages that come along with Spider IDE. So the two important packages that I will be talking about today is NumPy and Matplotlib. So NumPy is an open source package, and it is very important in graphics, and it is very important in machine learning and image processing, since images, we know that pixels are represented in the form of vectors. So NumPy provides an excellent platform to handle the pixels in its own vector or in its own native form, rather than converting the data to user understandable form, and making it even more computationally complex. I'll show the very basic syntax and very basic functions of NumPy. So whenever you want to import a package, you have to always give the word as import NumPy as NP. So I'll be running this in the IPython console since it will be, excuse me, since it will be easier. So NumPy has been imported now. So, okay. So what this function does is np.arange. Arange is an inbuilt function in the NumPy package, and reshape is also an inbuilt function in the NumPy package. So arange, what it does is it tries to get the numbers from 0 to 14. So when you print a, as you can see, it prints from 0 to 14. It is exclusive of the number what you specify, hence it's only from 0 to 14. What reshape does is it tries to convert it into a 2d 3 or nd array. Since I've given here as two arguments 3 and 5, it tries to create a 3 row and 5 column matrix. As you can see, 3 rows and 5 columns. Since the pixel, as I said, since graphic mainly deals with the coordinates in a homogeneous manner, NumPy is very helpful, is very useful in manipulating it. So the next inbuilt function is a dot shape. It tries to show how much, what are the dimensions of it, like 3 rows and 5 columns. Next is the dimensions of the matrix. Since it is a two-dimensional matrix, 2 is displayed here. Next, if you want to know the data type, you can give this function. Sorry. Int32. It is giving the integer value to since these are integer values, it's showing as integer. Next is the item size. 4. The size given to integer depends upon the system architecture and the compiler that you are using. So mine is giving it as 4 bytes to every integer, hence int32 here. Next is a dot item size. Oh, sorry, a dot item size is over. Next is a dot size. 15. So it shows how many numbers or whatever the objects are present within that array. So since there are 15 numbers here, it is displaying it as 15. Next is type of A. So if you want to know what type of matrix you are handling with, numpy.nd array. So it is showing the type of the array. So to create an array, it is very easy. You can write this statement. And the array is created. So if you want to create an array, you have to use the inbuilt function np.array. Next, if you want to print your matrix, you can use this code, this line of code. So it prints the array 2 3 4. If you just give it as a, it will print array 2 3 4. Next is so if you want a matrix with just zeros, you can use this command. It has created just zeros. This is useful if you want to have just a zero matrix or unit matrix in your computations. This command will create a unit matrix of integers. As you can see, it has given integers of 2 bytes each. So okay, so print, it will come as two. So okay, what this is, it's a three-dimensional array, two-dimensional arrays with 3 rows and 4 columns in each array. So next is if you want to create an empty matrix, you have to use this command. So okay, empty matrix means that it will create a matrix which is uninitialized. Hence, these are the random values that are created along with the matrix. So next, I'll demonstrate some of the basic operations that can be carried out on the arrays and with the help of NumPy. I'll create an array here. and I'll create another array with the help of arange function. So now I want to subtract these two arrays. I'll assign it to a variable and print it. So print C. So hence you can, since np.arange is from 0 1 2 3, so b's content will be 0 1 2 3. What this operation is doing is each element subtraction. So a of 0 minus b of 0, a of 1 minus b of 1, like that the subtraction is getting carried out. So 20 minus 0 is 20, 30 minus 1 is 29, 40 minus 2 is 28, and 50 minus 3 is 47. So the operations take place element wise. So as you can see, we are calculating the square of the individual elements in this command. Hence, since it is 0 1 2 3, square of 0 is 0 1 4 and 9. 0 1 2 3, square of 0 is 0 1, square of 2 is 4, square of 3 is 9. Okay, so in this calculation, what the function is doing is, it's basically treating 20 30 40 and 50 as radians, and it is and the sine function is taking it as input and calculating the radians of sine of 20, sine of 30 and sine of 40, and multiplying it with 10 each time. Hence you are getting this 9.1 minus 9.8, 7.45 and 2.6 as the answer. Okay, so next, if you want to carry out some comparison operations, like a is less than 35, so a is 20 30 40 and 50, the output will be true true false false. A is less than 35, yes, 20 is less than 35, that's why it is true. 30 is less than 35, that's why it's true, but 40 is not less than 35, hence false false. So what is the data type is boolean. As you can see, it's just true true false false. So if you want to find the sum of the some of the elements within the array, you can type this command and it will show the sum of the 20 plus 30 plus 40 plus 50 is 140. So I'll show some of the other like calculating the multiplication of matrices and dot product of matrices. So let's create two arrays. A, B. So if you want to see the contents of A and the contents of B, so if you just type A star B, it will carry out matrix multiplication. So matrix multiplication is like this row into this column plus this row into this column, this row into this column plus this row into this column. So it's basic matrix multiplication. But if you find the if you want to find the dot product of the matrices, then you have to give this command. So since we have learned in algebra the basic dot product of the matrices, hence this will be the dot product of A and B rather than matrix multiplication of A into B, like this. So next I'll explain other two global functions. Let's create a matrix. So the contents of B will be 0 1 2. So if you want to find the exponent, so exponent means like it will take the natural exponent e. It will everything, if the contents of B will be raised to the power of e. As you can see, e power 0 is 1, e power 1 is 2.78, e power 2 is 7.389. So if you want to find the square root of B, you can give this command and it will find the square root of B. So this is the very basic implementation and a very basic introduction of the NumPy package. If you are interested in learning more about NumPy package and if you want to go in depth and find out more inbuilt functions which are related to your application or application specific functions. If you need them, you can always go to this website, docscipy.org. You can always just google numpy tutorial python, and this will be the first website which will be come in which will come in the recommendations. And you can see there is many examples along with the outputs, and this is a very good starting place to learn more about the numpy package. If you're very much interested in machine learning and image processing, numpy is a very good package, and it helps in diversifying your applications and making your computationally intensive operations very quick. Next we are going to talk about is the matplotlib. So basically what matplotlib does is it tries to give a visual platform to your data analytic tool. It gives a visual, a graphic representation of your data. For example, if you want a histogram or a line graph or line chart or a pie chart, excuse me, or any other visual representation which will help you in learning more, matplotlib is a very excellent tool to help in visualization of the data. So I'll show some of the, again, some of the basic uh, syntax and basic functions of the matplotlib. So if you want to import matplotlib, you have to give it as import matplotlib.pyplot. I'm using within the matplotlib the pyplot package, hence I'm putting it as matplotlib.pyplot. Yeah, I forgot another feature of Python is that if you want to access a specific part of a package rather than the whole package, for example, matplotlib it will have many other packages. So I just want pyplot rather than importing every other package. Hence, I'll put it as matplotlib.pyplot. It is same as how we work in Java. Almost similar. It is similar to how we work in Java as PLT. So PLT dot plot 1 2 3 4. So what it tries to does is it tries to plot these points 1 2 3 4 on the graph, and it gives the y label. Plot dot show, it shows the graph. So I'll run this. Okay, it took some time. So as you can see, it has plot the numbers 1 2 3 4. So what it's taking is 1 1 2 2. So x and y as same. So just giving like this, it will take as 1 1 2 2 3 3 4 4. So x and y coordinates will be equal if you just provide arguments like this. So if you want to provide if you want to have different x coordinates and different y coordinates, then you have to represent the commands like this. So these will be the x coordinates and these will be the y coordinates. So x1 y1, the point will be pointed at 1 1. The second point will be plotted at 2 4. The next point will be plotted at 3 9, and the next point will be plotted at 4 16. What this third argument does is it will basically try to implement if you want a line or if you want dots or if you want any other tool or any other representation of the points which help you in understanding. So RO, what it does is it will put round points with red color. What this statement does is it will try to extend the x-axis from 0 to 6 and y-axis from 0 to 20. We'll run this now. As you can see, 0 to 20 from y-axis and 0 to 6 on x-axis. The point is plotted at 1 1, first point, second point 2 4, next point 3 9, and the next point 4 to, 4 16. Okay, so next I'll show the demonstration of various tools like various other representation tools, like I said, lines, dashes, triangles and circles. Okay, so we'll run this now. So as you can see, these are in triangles, these are blue squares and red dashes. green triangle, blue square, and red dashes. np.arange, as I had explained earlier in numpy package, the a range it takes basically from 0 to 5 with 200 millisecond intervals. So in the next plot, in the next example, we'll see how to create subplots. Meaning, in a single figure, creating two plots, two separate plots, and how to write the function. So when you see T1 and T2, plot if you want to in the first figure, if you want to have just the operations on T1, you can give uh, operations on T1 and T2, combined operations on T1 and T2 with T1 as x-axis and T2 as y-axis. You have to specify like this. So this will be included in this, all will be included in the figure 1, but in the figure 1 these two will be separate subplots. I will show how this runs with an example. So as you can see, two figures are created. So the first one will be the dampened oscillations of a pendulum, as you can see, and the next one will be a cosine wave, as we have specified here, cosine. So it will start, it's starting at the 90 degree amplitude, and then it has a phase of 90 degree, and it's starting here, and this is the dampened oscillations. So in the next one, this is also how to create multiple figures and subplots within them. So in this much line of code, initially a figure will be created. Within that figure, two subplots will be created. In this much line of code, in these lines of code, another figure will be created, and for that as another subplot will be created. So if you don't specify the subplot, you'll take a subplot as by 111 by default. So I'll try to run this now. So as you can see, two figures are created, but these two are the subplots within one figure, and this is in the separate figure. So next one will be the last example will be of how to display histograms. So if you want to display histograms, you have to use this. You have to use this to show the histograms, and this much line of code to display the histograms. So basically this will try to do the bins, the spaces between each bins and the height of the bin, X label, Y label, and the title of your histogram, and text as to where is the mu point and the sigma point, and the axis, and if you want it in a grid format, and to show. So the random.seed is to, since we are using a normal distribution of points, so this is setting for reproducibility purposes. I'll run this code now. We've got the histogram. As you can see, so mu is 100, sigma is 50. So as you can see, this is the probability and the histogram. Okay, to give a summary, so this is the conclusion. This is the ending of what I'll be talking about. To also summarize everything, Anaconda is a very useful tool for data scientists and statisticians, and those who are very much enthusiastic in data sciences. It provides an open source tool, and it helps in connecting various people and thus improving the field of data sciences, since many ideas can be pitched in, and your ideas will be considered if they are good, or if they are better than already existing ones. And it also provides integrated framework for Hadoop and distributed systems and distributed file systems, which are very important in big data and data analytics. And it also provides 720 plus packages, so that is a very important point. So that is a very important point, since 720 plus packages, it's saving you a lot of time by pre-installing 720 plus packages. Uh, So that is the advantages of Anaconda if you are very much interested in the data sciences, and that's how it will provide, it will give you an edge in data science field. So coming next to the Spider IDE, Spider IDE is basically a cross-platform IDE, integrated development environment, which supports Python and R. It is licensed to, excuse me, it is licensed and released by MIT. So the features of it is gives static code analysis, code completion, code helping, and indentation, and helping with indentations and all other quality of life stuff. So that's about Spider. So next, going to the installation, as I had said, if you Google Anaconda Python, the first link will be download Anaconda now. When you click on that, you will get this web page. Depending on your OS and your architecture, select the required installer. Go to your downloads. Then you have the file. And when you click next, I agree. You have to agree to the terms and conditions. And at the end, the Anaconda will be installed. So to confirm whether Anaconda has been installed or not, type Python, and it will show the version of Anaconda and the Python version that has been installed. Then okay. So as I said about file, edit, search, source, run, static code analysis, as you saw, it is very much amazing, as it will try to improve the quality of the code, and it also provides an assurance, quality assurance to whatever the code you run. And the debug feature, as it is very important if you write very big programs, and if you want to open multiple Python consoles, and the tools Python manager environment, if you want to set environment variables, and if you want to customize your IDE, you can do it here, and the help. So as a concluding note, I would like to end with saying that my personal experience with Anaconda has been very amazing, since as I showed everything, as I said everything with an example, like it shows the spaces, it helps in code completion, like you don't have to necessarily remember all the syntax, and since it provides many pre-installed packages, that reduces the hassle of installing everything from the scratch, because the problem of that is you have to install many other prerequisites for that package to work. So if you're not well versed in pre-installing other packages, or if you're not well versed in command line arguments like in Ubuntu or other OSs, then this will be very helpful for you, and it will save you a lot of time, since everything will be installed properly, and nothing will be messy. So if you want to give me an example, like if you want to install Android Studio, then you have to download a JDK and install it properly, and specify it in the environment variables, as I had shown, by going to properties, this PC properties, advanced settings, environment variables. So if you mess up something there, there's a possibility that your system will crash. So you have to be very careful, and you have to know what you're doing while installing this stuff. Hence Anaconda provides a very safe way of installing packages. Oh, and also as a conclusion, and also as an ending note, there are many versions of Anaconda. So the basic Anaconda with most of the packages is free. So other versions of Anaconda, like if you want it for specific industrial purposes, or specific data science research purposes, then there are separate, or for artificial intelligence purposes like deep learning, then there are separate other versions of it, and they are and you have to pay for it. Only this basic version is free. With this basic version itself, we can do so many things. So hence I'm concluding the video, and thank you for watching, and please leave a feedback, and I hope you enjoyed the video. Thank you.